Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, we're going to talk about peptide bond formation, which is how amino acids link together to form proteins. So peptide is a chain of two or more amino acids that are linked by peptide bonds. Amino acids may also be called as residues. You have dipeptides, which have just two amino acids, tripeptide, which has three amino acids, an oligopeptide, which has a few amino acids, usually less than 20, and a polypeptide, which has a lot of amino acids, usually more than 20. Finally, you have a protein, which is a functional polypeptide or a group of polypeptides folded into a specific shape. So what is a peptide bond? A peptide bond is a covalent bond that links the carboxyl group of one amino acid to the amino group of the other amino acid. This happens through a condensation reaction, meaning a molecule of water is removed. So a hydroxyl group from the carboxyl is lost, and a hydrogen from the amino group is lost. So the hydroxyl and hydrogen make water, and a C and N bond forms between the two amino acids. This carbon-nitrogen bond is specifically called an amide bond, but when it happens between amino acids, it's known as a peptide bond. And these peptides, they are always synthesized and read from the N-terminus to the C-terminus. The N-terminus is the end with the free amino group, and the C-terminus is the end with the free carboxyl group. This directionality matters in translation, where protein synthesis happens on the ribosome, protein naming and protein sequencing, and post-translational modifications. Due to the delocalizable pi electrons in the carbonyl and in the lone pair on the amino nitrogen, they exhibit resonance. And so even though the peptide bond is a single covalent bond, it has partial double bond character because of the resonance between the carbonyl oxygen and the nitrogen. Now this partial double bond character has two big consequences. One, the peptide bond is now planar. It cannot rotate freely. And the other one is that rotation in proteins only occurs around the bonds on either side of the alpha carbon. These bonds are sigma bonds, and these can rotate freely, but the peptide bond itself cannot rotate freely. This rigidity influences secondary structure like alpha helices and beta sheets. Now let's talk about breaking a peptide bond. Peptides need to be stable for enzymes to perform their functions, so they don't break apart easily. But in order to digest proteins, we need to break them down into amino acids. So in organic chemistry, amides can be hydrolyzed with water using acid or base catalysis. But in the body, hydrolysis is catalyzed by hydrolytic enzymes like trypsin and chymotrypsin. They're both quite specific and only cleave at specific points in the peptide chain. Trypsin cleaves at the carboxyl end of arginine and lysine, whereas chymotrypsin cleaves at the carboxyl end of aromatic residues like phenylalanine, tyrosine, and tryptophan. You don't need to know the in-depth biochemistry of why they cleave it or how they cleave it, but you should know that they break apart the amide bond by adding a hydrogen atom to the amide nitrogen and a hydroxyl group to the carbonyl carbon, which is the reverse reaction as how it gets formed. That's it for today's episode. In the next episode, we'll talk about primary and secondary protein structure.